In this video, we're going to look at a more difficult application of integration by parts. Evaluate integral e to the 2x sine of pi x dx. Since the integrand is a product of two different functions, an exponential function multiplied by a trigonometric function, and U substitution will not solve this integral, we will apply integration by parts. Integral u dv is equal to uv minus integral v du. So we're going to let u be equal to e to the 2x. The remainder is going to be dv. dv will be sine of pi x dx. Alright, so let's write that down. U is equal to e to the 2x. Derivative of u is going to be e to the 2x multiplied by the derivative of the exponent, that is 2, times dx. dv is what is left over. dv is equal to sine of pi x dx. Integrate dv to get v. v is equal to, integral sign is negative cos, minus cos of pi x, divide by pi. We're reversing the chain rule when we integrate sine of pi x. So we're essentially applying the substitution technique, but because it's easy, we do it mentally. All right, let's put this in a box. Okay, so what we have is integral e to the 2x sine of pi x dx, and we have our integration table set up. So let's apply the integration by parts formula. So we have equal to u times v, e to the 2x times v, that's minus cos of pi x, divide by pi, minus integral v, that's minus cos of pi x, divide by pi, times du, that is 2 e to the 2x dx. So we get equals to negative 1 over pi, e to the 2x, cos of pi x. And let's simplify a little bit. So we have minus times minus is plus, and let's pull the 2 out. So we get plus 2 over pi. We'll take out 2 over pi because it's constant, passes through the integral. Integral e to the 2x, cos of pi x dx. Now we have another integral to solve. So this is the integral, and this new integral is kind of looks like the integral we had in the beginning, but instead of sine of pi x, we have cosine of pi x. So we have to apply another application of integration by parts. But it's important that we make the same choices for u and dv. In the first instance, we let u be equal to exponential function and dv be a trig function. We're going to make the same choices here. So we'll let u be equal to the exponential function e to the 2x. Its derivative du is equal to 2 e to the 2x dx. And we'll let dv be equal to the trig function cosine pi x dx. And integrate both sides to get v. v is equal to sine of pi x divided by pi. Let's put this in a box. All right, so what we have is integral e to the 2x sine of pi x dx, and we applied integration by parts to get negative 1 over pi, e to the 2x cos of pi over x, plus 2 over pi integral e to the 2x cos of pi x dx. Now we're going to apply another integration by parts, so we let u be equal to e to the 2x, du is equal to e to the 2x times 2 dx, dv is equal to cosine pi x dx, and we integrate both sides to obtain v. v is equal to sine of pi x, reversing the chain rule, sine of pi divide by pi. And let's put this in the box. Alright, so notice that we make the same choices for u and dv. u is exponential and dv is a trig function. Applying the integration by parts formula, we get u times v. So that's going to be e to the 2x times sine of pi x divided by pi minus 2 over pi integral, sorry, that's going to be minus integral v du sine of pi x divided by pi v times du, that's going to be 2 e to the 2x dx. Now 2 over pi is a constant, passes through the integral, so let's simplify this. We get e to the 2x times sine pi x divided by pi minus 2 over pi integral e to the 2x sine of pi x dx. So let's put all of this in the box, and all of this is going to get substituted back into this integral that we have here. Now notice how the integral e to the 2x sine pi x dx reappeared on the right-hand side of the equation. This is a loopy nature of this type of question, this type of integral. All right, so let's review what we've done. We started with the question integral e to the 2x sine of pi x dx. We applied integration by parts to get negative 1 over pi e to the 2x cosine of pi x plus 2 over pi integral e to the 2x cos of pi x dx. So then we did another integration by parts, and we obtained e to the 2x sine of pi x over pi minus 2 over pi e to the 2x integral of e to the 2x sine of pi x dx. So we're going to now substitute this back in, and what we get is I is equal to, we're just calling this integral I because it makes it easier to work with. So I is equal to negative 1 over pi e to the 2x cosine of pi x plus 2 over pi times e to the 2x sine of pi x over pi minus 2 over pi times I. This integral, we're calling that I. And notice that if we can solve for I, we're done. The question will be done, because we're looking for the integral e to the 2x sine of pi x dx, and we're labeling that as I. We have to do some algebra. That's all that remains. So I is equal to negative 1 over pi e to the 2x cosine of pi x, distributing the 2 over pi, and we get 2 over pi squared e to the 2x sine of pi x, and 2 over pi times minus 2 over pi I, we get minus 4 over pi squared times I. Now let's add 4 over pi squared I to both sides, so bring it over, bring this term over to the left-hand side, and we get I plus 4 over pi squared I is equal to negative 1 over pi e to the 2x cosine of pi x plus 2 over pi squared e to the 2x sine of pi x. All right, so all that we have to do now is factor out I times 1 plus 4 over pi squared is equal to negative 1 over pi e to the 2x cosine of pi x plus 2 over pi squared e to the 2x sine of pi x. So what we're going to do is just divide both sides by 1 plus 4 over pi squared, and divide the right-hand side by 1 plus 4 over pi squared. So the result is I is equal to negative 1 over pi e to the 2x cosine of pi x plus 2 over pi squared e to the 2x sine of pi x divided by 1 plus 4 over pi squared. This is the answer to the integral. So it's the answer to the integral, which is integral e to the 2x as sine of pi x dx. This is equal to what we have above. But of course, we shouldn't forget about adding the constant c of integration. Always add c at the end because it's an indefinite integral. All right, thanks.